base B, let's call it B, and we'll call this angle C over here. And we'll call this side A, and this will be side C. I won't label it though. The traditional formula would tell you that the area of this triangle is 1/2 BH, right? All right, but now we've also, though, combined this now, please, with the discussion we've also had recently, and that's how do you find the height? If you know this side length A and this angle C, how do you find the height? What is it? We did this when we were doing like the ambiguous case thing. H is equal to A sine C. You can work through that logic again if you're not convinced that we're all right about that. And then combined with the fact that the area is this, then that means that the area is 1/2 base times height, which is A sine C. So proof done. Isn't that what's in the box? Okay. So and of course, by the way, just like with the law of cosines, I could write down, we're only going to put this one on the board in the box, but we could write down two other formulas too. They're equally good for a triangle with labels A, B, and C. We also have that the area of that triangle is 1/2 BC sine A, and also 1/2, what am I missing? A C sine B, right? So there are a couple different ways you could write that. I just chose to use one set of letters to express it. But the point is the area of the triangle is 1/2 times side times the sine of the included angle would be the way to say it generally, right? And you could prove this pretty quickly in the way we just did. Here's one that, like I said, I will not prove for you, but you might be in a situation, and this is such an innocent question to ask, right? You might be in a situation where you have know the three sides of your triangle, but know none of the angles. It's a very innocent question to ask. What's the area of my triangle? Right? It's an easy question to ask. It's actually a little bit complicated to answer. Before I even put this formula up here, I think you could have solved it though. You would have first had to maybe find an angle using technology from yesterday. Yes? If you were in that three-side case, you'd have to find an angle, and then maybe you could use this formula or something. That would work great, and you're always still allowed to do that. But this is cool too, isn't it? It's called Heron's formula. And already you can look at it and you're like, that's beautiful. It's got a really nice kind of symmetry to it and everything. So you need to read the comment below if you want to know what we mean by S. By S we mean the semi-perimeter, okay, whatever, of the triangle. A, B, and C are the side lengths. But this is cool because it's a result that doesn't rest at all on any of the angle measures. It's just like plug in the sides and like go. That's cool. Heron's formula. Yes. It's half the perimeter. So 1/2 times A plus B plus C. Doesn't that sound like fun to use these new formulas? Aren't you excited to try them out? Aren't you dying to do these two triangles and find the areas of those two triangles? One small footnote. I'd like you to go and try it right now. Ready, go. But do it without the calculator. Okay, do it all without the calculator.
I don't know how
I feel.
I'm not like
You'll see. You'll actually thank me. Give me exact answers. Don't use the calculator. See, you see what I'm saying? You know, you're with me on this.
This is anarchy. Without calculator.
And the two lucky individuals who will be coming to the board. When you're ready. You can use which one? Yeah, I don't think you're gonna be able to do without a calculator unless you do Merrick's one. Yeah, the second one I'm kind of setting you up for success with those two formulas.
Oh, never mind.
Yeah, don't confuse this with the line.
Wow.
Just do one half the other side. But what is that?
Mr. Shea, do you want work? Do you want me to write the work?
Yeah, write a little bit of work. Show us how you got your exact answer. Oh gosh. I will be eventually asking you in today's lesson what the area of a sector is of a circle. So if you're bored and you're done with these two problems while they're being written up here, you can figure out before we get there. Figure out what the area of a sector is. If I tell you r and theta, how big is that piece of pie? There you go. So even without a calculator, you're able to do these, aren't you? Is this great? Aren't you feeling very special? 15 root 3 for the first one. Did you get that? And in a second, Rick's going to tell you what you should have gotten on B, maybe. Let's see how he did here. Like I said, if you're done, you can be thinking already, how do I find the area of a sector? Maybe you can beat me to it. Alright, listen up. So I don't have anything else to say about that. Are we good? Did you get those answers? 15 root 3 and 20 root 3. It's pretty exciting. I should have made them come out to be the same answers. That would have been cool. Wouldn't that have been cool? Wouldn't that have been great? How would we change this problem so it would come out that way? I need this to be 20. So what would you like to change there?
Change 5 to 8 by calculating on this.
Yeah. I'm thinking about it too. I didn't plan to ask this question. I was just thinking, how would we make this happen? We need this all to be 20. So maybe we change one of these things. I don't know, the 5. So this will be 6 times. Yeah, maybe we can make it work out nicely though. We need this all to be 20. So maybe the product of these could be 10 and 2 would be all we need, right? We could just change this to 10 and 2.
Wait.
No.
No.
No,
Change it to
20 and 2 or something. Or, huh?
Wait,
5 and
wait.
8. How about
5 and 8.
40 and then divided by? Would that work?
Doesn't make sense that if you make it smaller and then you go bigger, it's 16 and 5.
8 times 5 is 40. Divided by 1. Divided by 2 is. Oh, but then we still have another 2. You're right. So we need a 16 maybe. All right. So that's what we should change the problem to. That'd be fun because then they come out the same. Yeah.
There we go.
Good. You're right. So this is root 3 over 2 is the point there. Yeah. Would you like another interesting problem? Find the area of a regular pentagon. Inscribed in a circle of radius 3 inches. You know what inscribed means? Inside, right? Inscribed. We are going to do that.
I don't know.
You could write it as, what do we write it as, 20 over 3 or something? I'd probably tell you either. The hardest part of this problem is actually drawing a regular pentagon. I don't know, that's not super good. That is not super good. I'm going to try again. That's a little better. I don't know. Whatever. That's the hard part. Drawing.
What's the cost? Oh. You know that if we break it out here, you're like. Okay. The area that's there equals. So 72. Wait, is it 1/2 3 3 times 72?
So what's the way in on this? Are you guys getting? You're not done yet. How do you? 5 triangles? Is that what you're saying? I think I like that idea. So this is 3 inches also. What is? I guess we need the angle too. That's 72 degrees. How'd you figure that out? Oh. 360 divided by 5. I've done that. Okay, I'm with you. This is not what you're stepping in.
What you just call me?
All right, so the area of that triangle we can figure out. I think I know where you're headed with this. Area of the triangle is something. What is it? 1/2 side times side times sine of 72. It's approximately equal to something. I don't know. 4 point something? 4.3? Okay, we use the whole value though, of course, and then multiply that by 5. So area of the pentagon is equal to, I don't know, I just wrote whatever someone said. Is, whatever that is it 21, wait, 24? 21.4? Okay, approximately 3 sig figs, centimeter, or inches squared. Or what are we doing? Inches, yeah, inches squared, right? Okay. By the way, if you ever need to make a perfect pentagon, have you ever done this before?
Oh.
Take a strip of paper. And you, what do you do?
Tie like a knot.
Yeah, you just tie it in a knot. Now, the good question a mathematician would ask is, like, why? Why does that work? But it is provably true. It is provably true that if you do that, if you tie a knot, you get a, not just with a piece of paper, with a string too, you get a 180-degree angle at that corner there.
What?
You can fold it in, you make yourself a perfect penny.
Oh,
This. Free souvenir for you.
prove it to us.
Thank you so much. Thank you. That'll change your life. Sometimes at fancy hotels, they like tie your robe, the rope that goes around your, what do you call it, the belt that goes around your robe. They'll tie in a big knot like that. Or those stars people make, or origami, you know, yeah, and fold in the side, whatever. All right. So did you figure out the area of a sector yet? Did you figure it out? I mean, the way you could do it, I think a lot of you would probably start by doing this. I know the area of a circle, you said. I know the area of a circle, and maybe it's like a portion of that. And that would be a correct way of getting at this formula. I'll leave it to you to convince yourself of that. One thing I might say about this, though, is that if theta happens to be 2 pi, that is if you want an angle that is the whole bit, a sector that's that big, a sector that is the whole circle, then what do you get if theta happens to be 2 pi radians? What do you see here instead, if theta is 2 pi? Is this something you expect to see? You, of course, get just pi r squared, right, which makes complete sense, because if your sector is the whole circle, then it should agree with our area formula for a circle. Which, by the way, puts to mind this formula from back earlier. Do you remember the arc length formula from day 1 of this unit? That also makes me think, too, if that's like the arc length formula for just a small arc of radius of size theta. What if we let theta be 2 pi? What do you get? What formula do you get? If you look for the arc length of the whole circle, don't you get 2 pi r if theta is 2 pi? So both of these kind of provide for us, this provides like the generalized area formula for any sector of any size. If you like it to be 2 pi, knock yourself out. And this one is kind of the generalized arc length formula, which works for an arc of any size. But the area formula that we know and love are and the circumference formula that we know and love are kind of like consequences of these formulas, if you like to think about it that way. The area of a segment, this is really maybe more of a vocabulary moment rather than a math moment. Like, what do we mean by a segment? You need to know what we mean by a segment. We mean this region I've highlighted here. So I think after telling you what that is, using like the vocabulary lesson, I think you can find the area from after having me telling you what it is. How would you find the area of that? Especially given the things we've been talking about today. Yeah, the area of the sector, the whole thing, the whole piece of pie, you could find the area of. The area of the triangle, you could find the area of, and you could definitely like use the power of subtraction. That would be a thing you could do. Now I'll write the formula up here because it is actually kind of nice, but if you don't want to memorize it, you're forgiven. Just remember what we just talked about. It's the area of the sector minus the area of the triangle. No. Careful, I've said it 2 ways, so it's not like a huge formula, okay? So I said it here because I want to emphasize that, right? Sector, do you see it? Area of the sector, I just stole that formula from up above. Minus the area of the triangle. Wait, is that the area of the triangle?
Yeah.
1/2 AB sine C? Oh yeah, because A and B are both R, and C is the theta. Okay, so I think I'm with you, Mr. Chase. And then the 1/2 R squared could be factored out if like you wanted. So I don't know. I wouldn't necessarily, even though it's beautiful, I still might not commit it to memory. I don't know.
Oh, I love America so much.
So again, I put it in a box, but you don't necessarily have to memorize it per se. And now let's try a problem that requires both of these. The first one I think you'll find easy. I think the second one you'll find to be a little bit of a bear, even though it sounds, again, it's a really innocent question.
Chord.
Yeah, do you know what a chord is?
I don't know.
I mean, besides like 3 notes, say it once. A chord in a circle is what we mean, right?
I don't know what that is.
We'll draw a picture in a second. So the area of a sector, I've already given it to you in radians too. That's nice, right? This formula has to be with theta in radians, right? So what is the area of the sector? What will that be? What is it? 1/2. What did we say it was a second ago? 1/2. 5 inches squared, that's r. And we could draw a picture too, but I don't think we need to. This is a pretty straightforward application of this. Times pi over 9 radians. So I'm not super interested by this calculation. What do we get? With the units there, inches squared. All right, but this one I need us to think hard about. Definitely, let's draw a picture.
Take a seat. Don't be violent.
Make a decision. This country to make a decision. Watch that.
See ya. 6 inches. Yeah, so the picture.
That's Robin, man.
The picture is that, right? So I think it's pretty, like I said, it's a pretty innocent question, isn't it? It's easy to ask, but it's a little tricky to answer. What else do you need there?
Yeah.
In order to like run the formula we use.
We need the theta.
We need the. Yeah, it would be nice to know what that angle is, isn't it? But I didn't give it to you. So do you know how to find that angle? How might you do it?
No.
There's a reason we did these lessons in this order. Yeah, maybe you need the law of cosines to find that angle. What she said, yes. So theta is equal to, I think I remember how this goes. I did it a whole bunch last night in my homework. Chase. Cosine inverse of some stuff. Who was asking me how to like remember this formula? I don't know. Or were you, Alexis? Asking like how do you remember this?
Yeah.
Yeah. So you could just write it like Cassie did earlier. You could like write it out and then just solve it fresh, like she did here, and then solve for x each time you do it. But I think we probably have been doing it a couple times. Are you with me? Isn't it 8 squared? Yeah. Okay. You know, whatever. Centimeters is what I. That's what I meant. That's what I meant. So we will need a calculator to help us here. Now, actually, I prefer to do this in radians. Okay. Glad we had that talk. 1.46 radians. You can do it in degrees, but then you're probably going to want to convert by the time you get down to actually running the formula. Store this value in your calculator. I'm going to store it in A. I'm storing this on my. I don't want to put a box around that. There is more work to be done. There is more work to be done. So theta is 1.46. 18 times 3. And then now I'm ready to run that formula, right? Like what's the area? But do it carefully, because I think if you don't do it in radians, or if you do it in degrees, and then you go like, make sure your calculator's in radian mode when you do the sine of the angle, if it's radians, all this stuff. Make sure you get the right answer. What is this? 6 squared times theta minus sine theta, where theta is this stored value on your calculator, right? So you should get that the area is approximately something. I don't know. I haven't worked it out yet. Just make sure you get the right answers, okay? Get 8.38. Centimeters squared. Sorry. Yeah, that's right. Keep in mind that you don't have to use that secret formula if you like. If you want to find the areas individually first, that'd be fine. The area of the triangle is, if you did it individually, is 26.3 approximately. The area of the sector. And the area of the triangle separately is 17.9. And then you could subtract. Carefully. Okay. So yeah, just be careful with these. Make sure you're entering. Make sure you're careful as you were. Just like when we were doing arc length and all that. just be careful that you're like using radians when it's needed. The formula I gave you for the sector area is required. That only makes sense, but that's data is value in radians. The homework tonight is some problems from the book, but then it also tells you to look at this worksheet too. How about we just do the odds? Maybe, or the evens, maybe, whatever. No, there are a lot of problems on this, so just do like after. It says, do you think those problems on homework? These look at additional worksheets. The homework is to do the book problems and to do the odds on this.
So you said just the odds?
Yeah, just do the odds. I mean, I think if you want to do them all, you can, but you kind of get the idea, right? So,
Yes, sir.
2,000 of these. Sorry, go back. Yeah, so let me just clarify. On the homework sheet it says homework 8, and it lists some book problems. And then it also says, and supplemental worksheet. This is that supplemental worksheet. Yeah, homework 8 is a couple book problems. It's not very sizable. There's a couple book problems, and then, like I said, just do maybe the odds on this worksheet, right?
Just odds.
Yeah, just because if you want to do more, that's fine, but I think you'll get the idea. I mean, there's only so much of this you need.
Yeah. No, 8 is